Hello everyone, welcome back to my channel. Today let's go over a medium question that I finally solved on my own after a lot of trial and error. I literally sat here for like 2 hours trying different approaches and I finally got it. So I'm ecstatic about that and let's go over it. So you have a one index binary string of length n where all the bits are initially 0. So basically fill this of the same length with 0 and then flip them one at a time. And then what we're going to do is check if everything from 1, so it's one index, meaning everything from the beginning up to I is only a 0. So that's what you want to do, but that's not the hard part. That took me a long time to figure out. So let's say clone is going to be 0 times length of flips, and then let's print clone. This might take a while because again, I did figure it out on my own, but it took a very long time and a lot of trial and error. So let's try it again. So here we have this. And then now for I in range length flips, let's call this current is flips of I minus 1. So this is confusing because 3 is really supposed to edit index 2. So this is actually your index. So now you're going to do clone of cur index equals to 1. Let's print clone so you can see. Okay, so now, 3 is modifying index 2, 2 is modifying index 1, 4 is modifying index 3, 0, 1, 2, 3, 1 is modifying index 0, 5 is modifying index 5, which is the last one, 0, 1, 2, 3, 4, index 4, sorry. So now what we want to do is try to find how many bits are inclusive, aka if there are any zeros inside of the current subarray. So clone of up to I plus 1. Let's print now. Let's do this. Okay, so if there are no zeros inside of now, then we can go ahead and increment, because if there are zeros in now, that means that basically this is not valid, what it says right here, and the rest also have to be zeros, because basically, okay, so it'll make more sense when I just show you, but basically now we just have to find if 0 is not in now, then we increment result plus equal to 1 and return the result. So that technically works, but again, it's way too slow. So that's initially what I came up with. According to the instructions here, right, everything here is a 1 and all their bits are zeros, because if everything up to the current point is a 1, then you also know that everything else must be a 0, because we started with zeros initially, if that makes sense. So for example here, if everything up to this point, which we just modified, is a 1, then we know everything else can't be a 1 because we haven't modified that yet, right? And then this is the furthest we've reached up to this point. If everything up to this point is a 1, then we also know that everything else has to be 0 because we already counted this one, right? This was already a valid 1. And then for the point 4, for example, 0, 0, 1, 2, 3, again, everything to the right, right? Everything to the right has to be 0 because we started with zeros. And I guess this just works in that kind of a way. But this is way too slow. So instead of saying, because this is n again, so the trick that I came up with is to keep track of the subarray sums at each turn. So if we print now, and let's also print flips of I, what you'll notice, okay, so instead of flips of I, let's print clone of I. So as you'll notice, this is the rearmost element. Okay, so here you can see that we've incremented the sum by 2. Why? Because this guy is plus 1 and this guy was a 0, now turns into a 1. So what we're going to do is, if the current index we're on, if whatever we're trying to currently flip, which is 1, was in our scene category, then we have to increment the subarray sum once more. So subarray sum plus equal to 1. Let's go into print subarray sum, because we know that we're going to add another one, right? No matter what. So let's print this. Okay, so that's not correct because clone cur index. So let's see, or clone of I think. Okay, clone of I is correct because again, clone of I is the rear one, not cur index, sorry, because cur index could be 1 when we've already reached this point. So we want to add whatever's the rearmost, because if it's 0, then the sum doesn't increase. If the rearmost is 1, then it increases by 1, right? Because the whole thing can only have 0s and 1s. Cool. But this doesn't reflect this change, and this is where the hard part came in, because now what we have to do is make a set called scene, add I, right? And what we're going to do is scene and I and current. So current index. And what that's going to allow us to do, let me get rid of some of this. So if the current index is less than I, right? If it's less than I, that means it's already been visited previously. And then if the current index is less than I and the current index is 0 at this point, then that means we have to increment it again because it changed from whatever we had before, right? So for example here, let me see, current index and I. So if the current index is less than I, right? Current index is less than I, our sum was 2 here, then we have to increment the sum one more time to get 3. One more time to get 4, because we're at 3 right now. We already added this one at the rear, but this guy was already seen before, and it's less than the current I. Then we have to increment it one more time because we're changing something. Current index, we're changing something that we have already seen before, right? So if cur index is less than I, then subarray sum plus equals to 1. And let's print now and subarray sum. So let's just check our work now. Okay, cool. This is really important because just because we added this one doesn't mean that we can only increase by 1. We can also increase this 0 by 1 as well, because this is just opening it up one more time, right? The flips in the beginning could have been changed. So, sorry, not flips, clone could have been changed. So also, as we're iterating one more, this guy could be a 1, whereas we had a 0, and then this other guy previously could also be 1. Could also change from a 0 to a 1. And in that case, now we have the subarray sum. And how do we check that there are no zeros inside of this? So if subarray sum is equal to the length of the current subarray, which is I plus 1, 0, 1, 2, 3, then we know that there are no zeros because there are only zeros and ones in the whole thing, and then we can increment result. So that's the trick that I came up with. Took me quite a while to do that. And the good thing is this is n. You don't even need this now because we're just using the index. We just want to get the length, right? And we're just taking care of the subarray sum anyways with the modifications. So as you can see, it passes all test cases and it's pretty efficient, which I'm kind of surprised about because usually my own solutions aren't very efficient. But again, it did take me quite a bit of trial and error and banging my head against the wall, but I'm pretty proud that I did it at the end. So that's it for this video. Thank you for watching. Hopefully this explanation wasn't too bad, and thank you for watching and stay tuned for more.